is a video over 3.5 notes, and these are derivatives of trigonometric functions. This is an interesting chapter. It's kind of hard to go about this, explaining why we have these. But what I'm going to do is show you how we take the derivative of a trig function graphically, and that should lead us to some conclusions about what the derivative of sine of x is. So what I'm going to do is I'm going to graph the derivative. And so the first thing I'm looking at are horizontal tangents. And those are my maximums and minimums. And what I know is that the slopes of those lines are 0. So at those x values, I plot a value of 0. Okay? And so the next thing I want to do is go through and I want to look at about what's happening with these slopes as I go along this function. So what I see here is that the slopes are 0. They're getting more steep, but they're negative. So if I'm going through all these slopes here, then I'm going to start plotting the points that are getting more and more negative. And then as we approach this minimum value here, my slopes are getting less and less steep. So they start to go back up like this, okay? And then the slopes get steeper, they get positive, and then they get steeper and steeper and steeper, okay? And so then, and then over here, they start to get less and less steep. So as I'm graphing this, then I'm getting this type of shape here, okay? Let's go here. I kind of get the similar shape here. These slopes are positive. They're getting more and more steep, so the value of the slope is getting larger. And so if I go, okay, so right here, they're positive, but they're not very large, okay? But they're larger and larger here, okay? They're steeper. And then they go back and approach 0, okay? And then over here, they're negative. So I'm getting the same kind of pattern that I am, you know, for each of these periods. I'm getting the same kind of pattern here. And so what happens is that these slopes are negative. So they're getting more and more steep right around here. And then they're getting less and less steep. So the interesting thing is that my derivative gives me this curve, okay? And this curve almost looks a lot like the sine function, but it's just a little bit different, okay? It's shifted over. And the one thing that this red function looks like, this looks like the function cosine of x. So because I drew this derivative of sine and I got a cosine graph, then we can come to the conclusion that the derivative with respect to x of sine of x is equal to cosine of x, okay? And so little did you know, folks, that these were related, okay? All right, let's take a look at another one. Let's see what happens when we take the derivative of a cosine graph. So first things first, I'm going to plot my maximums and minimums, and I'm going to plot those values on my function here, and here, okay? And then I have another one over here. So let me graph that one and plot that here. Okay. So I have those. Now what I want to do is I'm going to go across my function, and as I'm going across, my slopes are positive. Okay, they're getting more and more steep. And then right around here, they start to get less and less steep, and they go back and they approach 0. Okay, and then right here, we're at a slope of 0. So my slopes get positive. Okay, and they get more and more positive, and then all of a sudden they start to go back and they approach 0 again. Okay, all right, if I take the slopes on this portion of the graph, all right, they turn negative. Okay, they get more and more negative, they get steeper and steeper, and then right about here they start to level off and they go back and they approach 0 again. All right, so if I go and graph those points and graph those slopes, all right, then I get some sort of shape like this, all right? And then at this minimum, my slopes then turn to positive, so I'll be above the x-axis. My slopes are positive. They get pretty steep right here, and then all of a sudden they start to level off and they go back to 0 again. And so I get this general shape of the graph. Okay, we keep getting this similar type of graph here, all right? And the question is, what's this graph? And this graph looks like a sine graph, but it's the opposite. This graph is negative sine of x. So what I end up having here is I get this. If I take the derivative with respect to x of cosine of x, I end up getting negative sine of x. So sine of x gives you cosine of x, but cosine gives you negative sine of x, okay? So those are the basic ones, and those are the ones we're going to refer back to. Now, I can use these two derivatives to help us with derivatives of the other trig functions, okay? Now, we don't have a rule for tangent of x, okay? But what I can do is I can replace this with sine of x over cosine of x, okay? And when I do this, I can take the derivative of this because I know the quotient rule, okay? So here's my high function, here's my low function. And so my high function is sine of x. Okay, my low function is cosine of x. The derivative of my high function is equal to cosine of x. The derivative of my low function is equal to negative sine of x. Okay, so what I want to do is to show this derivative, then I'm going to do low, so I do cosine of x, times the derivative of the high, which is cosine of x, minus the high, which is sine of x, times the derivative of the low, which is negative sine x, all over low. Okay, so all over cosine of x quantity squared. Okay, now if I simplify this up in my numerator, we're going to want to simplify this. I end up getting cosine squared of x, and then I get plus. So negative times a negative gives me a positive. I get plus sine of x squared, or sine squared x. So plus sine squared x, and this is all over cosine squared x. Okay, so with the one cool thing I know about this is that cosine squared x plus sine squared x, that's equal to 1. So I get 1 over cosine squared x, and then 1 over cosine, folks, that's just secant. So I can rewrite this now as a single function as secant squared x. So the conclusion that we make is that if I take the derivative with respect to x of tangent of x, then the result is that I get secant squared x, which is pretty cool. Okay, so what I want to do here, let's go ahead and do the next one, and that's secant x. Now, I don't have a rule for secant, but I want to rewrite it using sine and cosine. So I'm going to write d dx of 1 over cosine of x, okay, and I'm going to apply the quotient rule to this as well. Okay, I can take this derivative. So my high function is equal to 1. My low function is equal to cosine of x. Okay, the derivative of my high function, my d high, is equal to 0. And then d low is equal to negative sine of x. Okay, so to find my derivative, I'm going to do low. So I get cosine of x times the derivative of the high, which is 0, minus the high, so minus 1, times the derivative of the low, which is negative sine of x, and this is all over low squared, so cosine squared of x, okay? So now what I want to do is take a look and see what I've got here. I end up getting cosine of x times 0 is 0. Negative 1 times negative sine of x gives me positive sine of x, divided by cosine squared of x. Okay, so now the interesting thing is that I can still simplify this, folks. Okay, I'm going to rewrite this as 1 over cosine of x times sine of x divided by cosine of x. Okay, And I can simplify this, and I know that 1 over cosine is just secant x, and then sine over cosine is tangent x. Okay, so the derivative of secant, so the conclusion that we can make here is that the derivative with respect to x of secant of x is equal to secant of x times tangent of x. Okay, so another rule here. All right, let's check out cotangent. Okay, so if I do cotangent, then I'm going to take the derivative with respect to x of cosine of x over sine of x. Okay, and I'm going to use the quotient rule here again. So my high function is equal to cosine of x. My low function is equal to sine of x. My d high is equal to derivative of cosine is negative sine of x. Okay, and if I do d low, then the derivative of that is just cosine of x. So let's go ahead and take our derivative, and so we get low, so sine of x, times the derivative of the high, which is negative sine of x, okay, minus the high function, which is cosine of x, times the derivative of the low, which is cosine of x, all over low squared. So all over sine of x quantity squared. Okay, so now if I multiply these two together, I get negative sine squared x minus cosine squared x all over sine squared x. Okay, now I want to be able to try and simplify this. The one thing that I can do here is I can factor out a negative out of my numerator. So if I factor out a negative 1, then I'm left with sine squared x plus cosine squared x all over sine squared x. Okay, now this part, folks, becomes 1. So I get negative 1 times 1 is just negative 1 over sine squared of x. Well, that's just the same thing, guys. 1 over sine is the same thing as secant. So this is negative cosecant squared x. Okay? And so the conclusion that we can make is that the derivative of cotangent, d dx of cotangent of x, gives me negative cosecant squared x. Okay? So pretty useful stuff. All right, let's try one more. Let's try cosecant, and this is just 1 over sine, so d dx of 1 over sine of x. And my high function is equal to 1, my low function is equal to sine of x. So d high is equal to 0, and then d low is equal to cosine of x. All right, so now if I apply my quotient rule here, I get low, so sine of x times the derivative of my high, which is 0, minus the high, so minus 1, times cosine of x. And then this is all over sine squared x, or sine of x squared, doesn't matter. All right, sine of x squared. So now, okay, this part becomes 0, so I get negative cosine of x over sine of x times, and then I'm going to do sine squared x. Okay, I'm going to split it up here in a second. Okay, so what I can do here is I'm going to split this up and simplify it. I'm going to do negative 1 over sine of x times cosine of x divided by sine of x. Okay, and so what I'm going to do here, negative 1 over sine is negative cosecant of x, and then cosine of x over sine of x gives me cotangent of x. Okay, so this is simplified, and the conclusion that I make that d dx of cosecant of x is equal to negative cosecant of x times cotangent of x. Okay, and these are the derivatives. Okay, so let's write all these down. Okay, and I want to show you how I remember them, because you do need to have these memorized. So here's what I know. The easy ones that I know, the first one is d dx of sine of x is equal to cosine of x. Okay, I know that the derivative with respect to x of cosine of x is equal to negative sine of x. These are the ones that are pretty easy. And I use these ideas, and I use these to help me with the rest of them, okay? So if I take the derivative with respect to x of tangent x, okay, then I know by my rule what we just did is that I'm going to get secant squared x, okay? If I take the derivative with respect to x of cotangent x, then I get negative cosecant squared x, okay? And then if I take the derivative with respect to x of secant of x, then that's going to give me secant of x times cotangent of x. And if I take the derivative with respect to x of cosecant of x, then I get negative cosecant of x times cotangent of x. Okay, so let me show you how I remember these. Okay, sine and cosine is pretty easy. All right, but the way that I remember these, okay, here's the first thing that I notice. I notice that if I take the derivative of sine, tangent, secant, my derivatives are all positive. Okay, if I take the derivative of a cofunction, meaning cosine, cotangent, cosecant, then my derivatives are all negative. Okay? Now, here's the other thing that I remember. I made a mistake down here. This should be tangent x. Sorry, folks. A little ahead of myself. Secant x times tangent x. Okay? So, the other thing that I remember is that sine and cosine are related. So if I take the derivative of sine, I get cosine. But if I take the derivative of a cofunction, I get negative sine. Now, I know that tangent and secant go together, because when I take the derivative of tangent, I get secant squared x. If I take the derivative of secant x, I get secant x times tangent x. Now, here's what I remember. I remember that if I take the derivative of secant, that secant is also in the derivative, okay? And that if the other one, tangent, I know I get secant, okay? And then the interesting thing is that the cofunctions are just the opposites. They're just the cofunctions of the derivatives, okay? So what I would do, guys, is I'd go back and watch this maybe a couple times if you didn't miss something, but these we need to have memorized, okay? And I'll go through this one more time how I memorize them. Sine and cosine are pretty easy, okay? I know that tangent and secant are related. If I'm taking the derivative of secant, then I know that secant is in my derivative along with tangent. Then I know that tangent of x is equal to secant squared x, okay? Now, the cofunctions, cosine, cotangent, cosecant, those cofunctions, the derivatives of those are always negative. And then the derivatives of cotangent and cosecant are the cofunctions of the derivatives of tangent and secant. So I get negative cosecant squared. This is secant squared, this is cosecant squared. This is secant x tangent x, this is cosecant x cotangent x. So that's how I remember them. I try and remember certain pieces, and then the other things have to go another way. So I hope you enjoyed this video. It was a little long, but get started on the homework. Thanks.